Hi guys, we have a new topic for today. It's about change of draft in water density. So this is the topic now, guys. Uh, Change of draft due to density of water. Due to density of water. So this is the formula, guys. Change of draft due to water density is your displacement times the salt water or constant minus your present density over your present density times your TPC, your present TPC, and times 100. So this one is your displacement, your present displacement, and this is DD is your present U density or dock water density, and TPC is your salt water which is of your current graph. So you can use also this formula and getting the change of drought to water due to water density by calculator by density times your uh, salt water minus your present density over your present density multiplied by TPC multiplied by 100. So let's start, guys, and this one start with this one. This is one questionnaire. It is about Envinara. He is now fully loaded of a summer draft. And what will be her new density, new draft if she floats in a density 1.015. So he's already fully loaded and he's floating in 1.015. What will be the draft for this density? The formula, guys, is density times salt water minus your new density over the new density times TPC times 100. So the displacement is 30,844. So to show you how I get this density is summer drop. The maximum summer drop is of MV Nara is 9.550 and displacement is 30,884. So his displacement is 30,884, which is this one, and the drop will be 9 point. This is his displacement and times saltwater density, his present density is 1.015 over new density is 1.015 times TPC. What is his TPC of this one? The drop. So TPC is 35.46. TPC is summer drop is 9.55 and mean kill is mean is 9.55 and this TPC is 35.46 or TPC is 35.16 of 9.550. So 35.96 and the answer, guys, will be 0.086 0.086. Okay, so this is it, guys. This displacement is this one. The new density is 1.015, and your new density is 1.015. This place, the TPC is 35.46. This one, and times 100. The value would be, change of drop will be 0.086. So this value, you add it to the initial drop, and you will get 9.036. Remember, guys, when your when your initial or present density is less than the salt water, your final drop will be greater than your initial drop, or or your if your density is less than the salt water, your change of drop should be added to the initial drop. So you add these two, so you will get the 9.636, the final drop. Okay, so the final drop will be 9.636, which is this one. So you add this one, then your final drop will be 9.636. This will be your answer. But the question stops here. No, the question stops here. What we're going to do is we want to know what will be the forward and updraft. What will be the forward and updraft? So to get the forward and updraft, this is what we're gonna do. For example, you're at birth and you are loading to reach this summer drop of 9.636 maximum drop. And once the loading has reached of 9.55 forward enough, even kill at your present drop, at your present drop. The foreman says, Chief, we have already reached the trimming draft, so let's go around a vessel and check. Once they check, both shipmate and the draft survey had the same readings of forward enough, which is this one, initial draft. So they are now to compute on how much will be their trimming amount for trimming holes of 1 and 4. So once they have taken this draft forward enough for port and mean draft, so the question is how much will they load, how much will be the amount for trimming. The formula will be this is the formula. The sinkage multiplied by 100 times your TPC times your TPC of your departure drop. Departure drop is 9.636, which is this one. This will be your TPC as interpolated, and this one. So the formula will be sinkage times your 100 times your TPC, which is 35.53. So the value will be 306. So we want to load it 306. Want to load it to holes 1 and 4. So the value is 306. 306 equals 306 divided by 2. So 53. So you put number 1, 153. You put in number 2, 153. And your graph forward and up will be 9.60 and up will be 9.67. They have a trim of 0.7 and your interrupt is 9.637. 9.637. So it's almost, but your should be here. So min drop is 9.336, which is this one, and your mid drop is 9.36. So you have a zero deflection. So we will check another. This will be your initial drop. 550 and 550. Okay. And 550. So you're trimming cargo to load or remaining cargo is 306. So you put here 306. Once you load 306, your departure drop is the same, 36361 36, and your sinkage is 0861. Okay, almost the same. So you distribute this to holes 1 and 4. 306. You have an even kill. You want to load even kill, no trim. So how much will you load in number 1? Number 1 should be 124, and number 4 would be 182. So number 1 is 184. Put here 184, 124. Sorry. And number 2 will be 182. Okay. What will be your drop forward? Forward will be 9.64. Up will be 9.64. And your mean is 9.363 and your deflection. But in our example, it says you have a drop trim of 7 centimeters. So we check 7 centimeters here. 0.07 centimeters. How much are going to load in number 1? So number 1 should be 155. Let's say 155 or 155. Let's see, 155. Okay, 155. 55. Number 1 would be 151. 5. and you have a trim of 0.7, forward will be 9.60, 9.67 in out. You still have a main of 9.636 and zero deflection. And here your drop forward will be 9.60, up will be 9.67. You have a trim of 0.07. Your mean is 9.636 and zero deflection. It will be the same with this one. See, your drop and your drop will be, forward drop will be 9.60 and 9.67 and up trim of 0.7. So we try the second questionnaire. Now we try this MV Panamax. This summer displacement. What will be her drop when we hit a density of 1.012, which is already loaded on our summer displacement. So what is the summer drop of Panamax is forward maximum drop is 13.295 and this displacement is 78849. So his displacement is 78849, which is this one. 78849 and his maximum drop is 13.295. And this is the formula. Also displacement is 78849 and the constant density minus your present density, which is 1.012, over your present density is 1.012 times your TPC. What is the TPC of this displacement? This TPC for 13 point maximum drop of 13.29 is 64.45. And so you got 64.45 times 100. The value will be, change of drop is 0.157. So his departure drop or summer drop, maximum summer drop is 13.295, which is this one. So 13.295. Okay, and this is the value. You add this one to the maximum drop, you will have a final drop of 13.452. Now I will explain later. Okay. Okay. Now this is the formula. Displacement or summer weight. This displacement of summer drop is this one, 78849 for his summer drop, and his present drop is density is 1.012 over his present density and his TPC is 64.45, which is this one, times 100. The value will be, change of draft will be 0.017, and this one. Look, when your present density is less than the salt water or the constant, your your density, your new density should be greater than your initial density. Again, when your present density is less than the salt water or 1.025, the draft, final draft should be greater than. When you say greater, if you see this density is less, you add the change of draft to your initial, which you will get 13.52. So I hope that is clear. Now the problem stops from here. The question is only how much would be your draft if your density is 1.012. So your draft will be 13.452 if you float in a density of 1.012. But this is now the another situation. Supposing in you are now at birth, you're loading, and foreman stops loading, and he says, "Chief, this is now the draft at present, which is 13.295, which is the initial, and up will be 295, 13.295, which is even kill, and your mid port will be 13.295, sub port will be, mid port will be 13.95. So since how much is your departure drop? So the departure drop will be 13.452. So they would compute, shipmate and the foreman will compute how much will a cargo to remaining cargo to load to reach 13.452. So by computation, so by this formula, this sinkage multiplied by 100 times the TPC of this departure, which is 64.53. So this is your departure draft and your computed interpolated TPC will be 64.54, which is this one. So by this formula, this will be the value of your remaining cargo. Okay, so your trimming hole will be 1 and 7. So we'll divide this one to your holes 1 and 7. Total cargo will be 1013. 1013. Sorry. 1013 divided 2. So that will be 506. So for example, you load here 506 and this one 507. Okay, how much would be, get the total weight 1013, and your draft will be trimmed by the head of 11 centimeters, but your main is you get the main, which is 13.52, which is this one, final departure. So trim by the head. So let's say you want to make it even kill. Trim by the head. 50. 50. 50. Or 56. 456. 456. Tama ba? 456. 557. How much would that be? Okay. Same cargo. 1013. And you now trim by the head of 3 centimeters. Okay. Little more. Take out 20. You take out 450. 16. 440. 440. 16. 573. 573. 573. Then 13. So 1 centimeter. Trim by the head 1 centimeter. Let's say you take 5. 435. 435. 435. 578. 578. So you have now even kill. So you have 30.45 forward, 30.45 up, and your mid will be 30.52, which is even kill and zero deflection. Okay, now we try to use the other one. Okay, still the same. Your recommended wrap is 10.12, so you put here 10.13, and your mid departure made will be 13.452, which is the same, and your sinkage is 157, which is the same. So we go to trimming holes. The cargo to load is 13.13, and we want to load even kill, which is 0, and how much will be forward? Number 1, 436. 436. 436. And number 7 will be 577. 577. How much will be your trim? So forward drop will be 13.45, 13.45, even kill and zero deflection. This one will be 4.36, 7 will be 577, and you have an even kill 13.45 forward, up 13.45, and zero deflection. So that's it, guys. And just remember, Just remember that if your if your present density is less than 1.025, then the value of your final drop should be greater than your initial. Or when your density is less than 1.025, the change of drop should be added to your initial, so this will be the value will be greater. So I hope in the Panamax vessel, um, the problem here was that in if you have a draft of 13.295, which is the summer displacement, if you were to float in a density of 1.012, what will be the draft? So the answer is 13.45 if we are floating in a density 1.012. Okay, so let's investigate. What is our Panamax? Okay, our our departure draft or the summer draft was 19.295. Forward and up will be 19.295, which is a mean draft of 19.295. The density of 1.025, because this is the summer draft, maximum summer draft, so this is in saltwater. So what will be his draft if our density is 1.012? So we put here, then we have, look, we have no added any cargoes here. We just change the density of 1.012. So his final drop will be 13.452, which is this one. 13.452 or this one. That will be his final draft in a density 1.012. And what will be his displacement is 79862. 79862. This one, 79862. Displacement is 79861. So the same. That's it, guys. So what about this Nara? So what will be his drop if he floats in 1.015? And his initial drop was 9.550. So let's investigate. Nara. Nara. So initial drop is 9.55. 9.55. 9.55. Sorry. 9.55. Spin drop is 9.5, and his since this is the summer drop, so it would be in salt water. Then he changed. What will be her drop? She floats in 1.015. So 1.015. So here drop will be 9.636, which is this one. 9.636, and her displacement will be will be 31188.6. 3188.6. 31887. So it's the same. So that's it, guys. So the final answer is 9.636, which is this one, 9.36, and this displacement is 31187. So that's it, guys. Hope you like it. Please share and subscribe.